Hi all, thanks for your time and enter this event. My name is David Xia, and I'm working in HUSKY Shanghai for more than 10 years as a capping specialist. Today we talk about the capping technology. This capping technology contains first from the filling line, then the triangle of capping. Next one is the important factor in capping. Number 4, capping defect. Number 5 is the nitrogen filling. The final one is the capping line chart. The first one, filling line. You can see this map. The equipment from the blow mold, filling, pepper, to the labor, finally labor. This is the whole line layout. It's easy to understand the filling line process from the blow mold to the lab. Today is important for us is the cap. Those pictures show us the main parts of the cap. You can see this tube transfer the closure and also the star wheel move the closure to the capping hand. This one is a capping hand work with the star wheel and align together to pick up the closure. And this picture shows us how to check the closure in the chuck, loose or tight. This is important for us for the capping. This picture is the capping hand. We already take off from the cap to check. Normally we wanted to check the spring, compression, and the capping torque as well. This picture is a spec plate. We wanted to check the knife is sharp or not. So this number 2 is a triangle of capping. We know three important elements of the capping. One is the closure. Another is the bottleneck finish. The final one is the capping, the application. We want to make sure the closure is good capping on the bottleneck. So let's talk about what's a capping. Capping is a process where the capping machine applies the closure over the bottleneck as quickly and efficiently as required to issue the part integrated within the container. The final objective is the goal of a screw capping is to deliver an application torque to a closure that result in properly sealed container, but at a force that also achieve an acceptable remove torque. That means when we apply the closure on the bottom, not only for the complete capping, also make sure that the remote torque within spec, not tight, not loose. Also make sure the lab performance is good. The third one is an important factor in capping. The first important from the closure, because many elements will influence the closure performance. Like first of you can see the rhythm, right? Normally we have a lot of rhythm on the market. Some rhythm has a slip engine inside. Some won't know. This also has a large influence on application performance. Part design for the band, you can see the band is afforded or interference and different sides of the crucial. Next one is the current. Current also important for the crucial because this will affect shakage and have huge impact on dimension of the crucial, which impact the application parameter also. Next one is dimension tolerance. Lab performance also. We should be validated in lab as crucial spec. Finally is the capping parameter. Before we try, we want to make sure this crucial have enough and a large capping window to apply. Then we move to the filling line capper. Should be a good application. This one shows us the crucial. We want to make the dimension report following drawing, crucial drawing. Crucial dimension inspection report show us we wanted to make sure crucial dimension with the spec as a drawing as a design requirement. This can make sure the crucial performance as a previous design, right? This one is a crucial performance. We wanted to check in Husky lab before the trial. Normally, we can see the crucial detail inside sample detail in this sheet. Current, project part weight, and crucial information, and the cycle time, reason, current. The right picture shows us performance test summary, which test we want to do, and what's the spec, and finally, what's the test result finally, right? Pass or fail, and the comments. What's the method we do? Next one is the neck finish. This is also very important for the capping. When the damage on the board neck finish, this will impact the capping. See, thread damage and the damage PP and the top surface corner damage and the flash. This not only impact the capping, also impact the lab performance, such as the damaged top surface corner. This will be influence the SST, secure cell test, and the part line flash will be impact the remove torque, increase the remove torque a lot. The final one is the capping. Cap crucial with accurate process parameter. The main process parameter is the closing torque and the pressure, chuck rotating speed, and also chuck fitness and alignment. At this moment, the capper has two different capper style. One is a magnetic isolate type capping hand. Another one is a servo capping hand. The capping hand vertically removed is a driver by a can. In a both capper hand is same. Only different is a return speed. Magnetic is controlled by the gear connect, and the servo by the individual servo driver. The torque, the capping torque is controlled by an adjuster magnetic. Another one, servo motor, is controlled by the servo driver. This we can easy to understand. The capping parameter, normally we can see the three parameter is important for the capping. First one is torque. Next one is top load. Final one is a capping handle rotating speed. Torque is give them the crucial stops from the rotating during capping. Direct way to turn the crucial to desired application angle. Normally, this unit is inch bounce. Method of control is a magnetic hysteresis type clutch. Another one is a servo drive. Top load is an orchestra. Load operates onto the crucial and the neck to increase a quarter mount to prevent the water from rotating. Typical value is 15 to 25 kilogram. The speed at this time we call this rotating speed is actually not from the line speed, because normally line speed we cannot adjust. This speed is the capping hand speed. Normally we can adjust by the HMI, such as a servo driver. This picture shows us the capping defect. You can see normally online the capping defect is a TEB defect and the high cap and the cup cap. This one is a broken bridge and this one is a torque under. This two pictures show us is a crucial not fully complete capping. This picture shows us this cork cap, the crucial enclosed thread on the bottleneck. Chuck fit. Actually, crucial fit in chuck plays a critical role on line efficiency. Tight fit will prevent the crucial from eating in the chuck, which may compromise crucial alignment. This will lead the cup cap too much of radius constraint will result in broken bridge. To lose fit will cause crucial to spine and lead to high cap. internal HUSKY method to measure this chuck fitment. First, we will use a figure to touch the crucial. In chuck is a complete sitting inside, and also check loose or tight inside or not. Next one is we will use a silicon to copy the chuck feature. And then analyze the chuck is a good fit with the crucial or not. This one, the capping speed. Capping speed will influence the will impact the cook cap, high cap with when the capping speed is not good enough. Like when the low speed will impact the high cap. When the speed is high speed, this will lead to a cook cap. So normally we want to balance water capping speed we want. Begin this picture. The high speed will lead to the cook cap, and the low speed will lead to the high cap. We want to choose the middle to balance cook cap and high cap. This one shows us the TEP behavior during the capping. When the TEP is tied with the bottleneck during capping, this will be related to the high cap. If the TEP is loose, is easy to capping, that means when we open the crucial, this will happen in Japan. So we wanted to balance the TEP design will to help easy capping and also achieve the TEP performance during the open. Other failure mode for the cook cap, bridge breaking, and tuck on. Crucial is a crash during a pickup, which subjects the bridge to excess loading and the case bridge breaking. You can see when the star will move the crucial, actually the star will already touch the crucial, make the crucial is deforming. And the chuck influence, contaminated chuck influence crucial pickup and lead into cook cap or miss chuck. We also can see this one, right? This one miss cap and the pickup is not good. And the final picture shows us the capping hand alignment issue may lead to cook cap. This alignment not good enough, offset between the cap hand and the bottleneck. How to catch the capping defect? Normally we use a high-speed camera to catch the capping defect and also monitor capping process. Is good for application is crucial or not. We can see this monitor capping with a low speed by the high-speed camera. Nitrogen filling does not impact capping. Firstly, we can see. Main factors of a nitrogen pressure variation One is from the bottleneck quality. We can scratch on the bottom surface. Another one is the nitrogen filling condition. Normally, we wanted to check inner pressure after the nitrogen filling to define the filling condition is good or not. Because if a large filling pressure will be related to the nitrogen retention performance. The gauge to measure the pressure. Normally we use the inner pressure, right? And the hand space in feed bottom and the part weight. The final one is the capping line chart. The capping line chart purpose is a capping line chart is a preliminary filling line evaluation to determine the compatibility of the occlusion finish system with the bottom equipment, confirm the capability of the occlusion to set a capping specification, and make adjustment to provide the occlusion sample for physical and compatibility testing. The object is to reduce any risk for mass production and deliver the best solution to customer. Normally, line chart typically produce 2,000 to 10,000 test package. This is based on the customer filling line speed. Line chart phase. Normally, we have a 2 phase during a line chart. First one is the prototyping. The second one is the production 2 phase. The prototyping phase, we want the occlusion made in the pilot mode. And the objective is to define a baseline validation of pilot occlusion functionally in production line development, minimize of the risk for design change after production mode has been made, customer acceptance for producing a production tool. The production tool phase, occlusion made use a production tool at HUSKY. The objective confirm our production tool's performance again against the baseline. Finally, customer buy off. So thanks for your attendance this event.